Hey everybody, let's take a look at sample problem 14.2 in the digital book, which talks about how to calculate instantaneous rates. Okay, so I have that right here. We can definitely take a look at all the information. And the answer is also given in the book if you wanted to take a look at how the book solves it. But let me get rid of this guy here. And then let me explain here. Okay, so the question asks for what the instantaneous rate is of the disappearance of this compound, right? And so the instantaneous rate at time 0 is the slope of that line at time 0, the slope of the tangent point to that line at time 0. And so this, let me erase it so you can see, this graph actually gives you the tangent line right here to use. Okay, and so there's a couple of ways that you can do this. You can use calculus. The slope of the line at a given point would be the derivative of this. Okay, and so you can find the function that this curve fits to. You can take the derivative of it and set that derivative equal to 0, and then that's the slope. But that doesn't necessarily work for many people in this case, because a lot of you may not know calculus. So we have to take an algebraic means of doing this. And the algebraic way of doing this is to find the slope of the line by looking at 2 points, and then remember slope is rise over run, which is nice because the change in concentration over change in time equals rate. And so if you want the instantaneous rate, you have to find the slope at that given point. And so that line forms a slope here. So what I'm going to do is I'm going to make sure that I plug in values here. Let's see here. So this is number 1. It's going to be negative no matter what. So that's cool. So let's see here. So 0.1 is going to be 0 and 0.1. So it's 0.1, 0 minus, let's see, this is 200. And this is in seconds. Right there it says seconds. And then for, let's see, minus 0.060. Okay, and that's in molar. So the rate here is 0.1 minus this, because it's change in y, which in this case is the change in concentration, over the change in x. That's like, go back to algebra 1 or geometry or whenever you learned that. Okay, and so it's change in y over change of x, which in this case is the change in concentration over change in time. So the only thing that we have to do is now do the math on this, which is 0.04 over negative 200, and it's important to have that negative sign in there because it tells us that this is decreasing or that it's disappearing. And so now we get out a calculator, and when we do, we get a rate of 0.0002, and the units on that is molar per second. So that's how to do that problem. Have a great day.